First of all, please look at the structure diagram of a Ritchie-Christian telescope attached to the GSO manual and observe what it should look like when it is aligned.
This is our goal. First, enter the center calibration mode corresponding to the OCAL electronic collimator number, and then open the software. Let's open the purple cross X first, and then open the green circle, and make it is about the size of the main mirror. First, start the installation. Now, I get a 2-inch adapter. Let's take it down and have a look. In the third step, we start to rotate it to see if there is too much displacement between the green circle and the mechanical circle of the telescope. If there is not much change, it means that there is not much problem. Then, we gently turn the tight screw. Both sides are gently.
You don't need to use too much force.
If we put too much force, we can do experiments to see what will happen. Let's tighten the screw with a little more force. We can clearly see that there are obvious changes and deviations in the picture. Therefore, you don't need to use much effort. Just make sure that the two screws are screwed, and ensure that they won't move or fall off. Now let's start adjusting the main mirror screws together. This is an RC6. If your RC telescope structure is not like this, then its focal plane screw and the main mirror adjustment screw are separate. And you can also learn from the final adjustment result. The first step is to adjust the mechanical circle around the primary mirror to concentric circles. You can observe that there is a bright arc area on its left. Let's randomly adjust the screws and see what will happen. Okay, we have loosened this screw, but this operation seems to be wrong, and we got even worse results. What about tightening this screw? It seems that this bright arc area has disappeared. Now the two arrow areas are darkened in the whole telescope. Our goal is to make this black circle more round. Let's try on another screw. We are doing very well now. Now, let's start looking at the fixing screws. Caution! Don't lock these screws at once, but lock them one by one. This will avoid offset, and this method is suitable for all telescopes. Now, we have increased the brightness, and we find what it is easier to observe this black circle. There still seems to be a little different center of the circle. I remember that it is to adjust this screw. Let's try another screw. Okay, we got it. Now let's start to use the offset function. Let's make the green circle bigger and make it as big as this mechanical circle. There seems to be little error. Oh no, we should act like this. Okay, we got it. First of all, we don't have to study how to adjust the secondary mirror. We will just have a try. First, try this screw. I feel it is wrong to loosen or tighten it. I will try another screw. It's wrong to loosen this screw. Tighten it. It won't move. Maybe another screw is the right one. Okay, let's go on. Now, we need to put a green trap around this reflective circle. Then put a red trap around the black circle. Oh no, something is wrong. Why did the adjusted black circle change again? In principle, when I adjust the secondary mirror, it won't move. Maybe I didn't lock the screws below just now. Okay, I will solve this problem. Now, continue to adjust the secondary mirror. We make it. Now we see that the green circle and the red circle are quite good. But we still need to see another circle. We must open the blue circle and put the red calibrator on them to see if they are in the same circle. If the blue circles have different circles, then the core of the star is not very positive. This is what we conclude. If your red circle and green circle are alright, but the blue circle is out of position, I suggest you move the red and green circles slightly to make the blue circle more round. We are lucky today, and the result is fantastic. Now, let's verify the spider rack, which is almost perfect. Finally, please take a look at the center. There is a different center here. Please ignore this. Because we only need to ensure that the 3 arrows are relatively concentric, and I can guarantee the effect will not be too bad. This may be a mechanical error or other reason, and nobody knows. Okay, this tutorial ends here. Hope that the above content can give you help. Thank you for your watching.